Welkom bij een nieuwe aflevering van de AI Innovators podcast, een podcast van Surf, waar we praten over wat we kunnen met artificial intelligence en machine learning. Mijn naam is Thomas van Himbergen en ik ben vandaag jullie host. Ik zit hier met mijn co-host Andres Steijaert en vandaag spreken we met onze Surf-collega Valeriu Codreanu over AI applications and research. Onze collega Duuk Baten, waar we normaal ook de podcast mee doen, die is er deze keer niet bij. Duuk heeft een weekje vakantie. Andres, nieuwe podcast vandaag. Hoe kijk jij terug op de vorige keer?
De vorige keer hadden we een hele leuke podcast met Casper van Leeuwen, die ons heel veel heeft kunnen vertellen over hoe je het toepast. Het was een hele mooie introductiesessie ook voor ons op het onderwerp. En vandaag met Vali gaan we wat meer de diepte in. Echt als deep learning AI specialist. Dus Casper natuurlijk ook. Maar Vali leidt het high performance team in Surf. En ja, hij weet er een hele hoop van af. Dus ik ben heel benieuwd wat hij ons gaat vertellen vandaag.
Ik ook. We doen de podcast in het Engels, want Vali praat vooral Engels, een beetje Nederlands. Dus we doen het in het Engels. En hier komt Vali. Vali joined Surf in 2014 as a machine learning consultant. And since the last year, he has become the leader of the high performance machine learning group at Surf. Vali, it's a pleasure to have you on the podcast. Welcome.
Thank you. Thank you for inviting me, Thomas.
So, Vali, you got your PhD in 2001 in Romania, and then you moved to the Netherlands to do a postdoc, first at Groningen and later at Eindhoven, if I'm not mistaken.
Yeah, it's just that I finished my PhD in 2011, not in 2001.
Oh, sorry. So you got your PhD in 2011,
Yes.
And then you moved to the Netherlands to do a postdoc, first in Groningen and later in Eindhoven. And then you came to Surf. So comparing Romania to the Netherlands, what are some of the differences you notice in academia, but also in the work culture?
Yeah, I think the work ethics here in the Netherlands convinced me to move here. I believe it was an important factor. So even during my PhD in 2010, I spent 8 months in Delft. And that was my first contact with the Netherlands, but I was officially a PhD student in Romania, but I had to do an internship. And then I liked a lot the work environment here in the Netherlands, and also the life-work balance. I liked very much here in the Netherlands, the fact that you could bike to work and things like that. I started to like that. That convinced me to do a postdoc, and the postdoc experience was very good in Groningen. I met a lot of very smart and interesting people that I worked together with in the scientific visualization group in Groningen. It was very nice. I would say that compared to Romania, the environment here was more focused and goal-oriented in some way, and it matched my personality.
Okay. And how did you come up to be a machine learning expert? So I introduced you as a machine learning consultant, but when we were growing up as kids, there was no machine learning.
Exactly.
It was not something you could choose to be. So is it something you actively moved forward to becoming a machine learning expert, or it's something you keep going just for something better to come along, and when it comes along?
I think it's maybe a mix of the two. So I like the whole idea that machines can learn. So this is a thing I like, but it's not my main drive, because so my PhD is in computer architecture. I used to design chips, so this is a bit further away than machine learning. So I'm at heart I'm more of an engineer than of a scientist. And I treated machine learning at the beginning as an application domain, basically. So my formation is in computer architecture, in efficient execution of computer code. And now the computer code I treated was machine learning. So that's how I got into it, and I started getting into it from Groningen, even from my postdoc in Groningen, but not necessarily the new hype, the deep learning, but the traditional machine learning bits in 2011. Yeah.
Right. And as you say, it's really a hype. People are jumping on it, and everyone wants to hire machine learning experts. So is that really true? Do you get a daily offer from one of the big tech companies?
Yeah, I would say in the past period you get a lot of LinkedIn requests and you get contacted by a lot of recruiters. So you need to turn off some settings in LinkedIn or turn them on such that you don't get.
I haven't figured that out yet.
Yeah.
Not that they're contacting me.
No, but it is true. So I think they go along the hype, all these recruiters, and there is indeed there is some truth to it. So. There is a scarcity on the labor market for good machine learning engineers, but there are a lot of machine learning engineers, and now it's a battle to find the good ones somehow.
And Vali, you just mentioned the word hype. Do you consider this to be a hype, the whole AI machine learning wave at the moment?
No, I think maybe when I say hype, I think it's a bit exaggerated in the sense that people believe we should use machine learning everywhere. So in this sense, so they don't see what our traditional approaches were for some problems, and we just try to use machine learning to tackle any problem. And of course, you don't have to use the same tool for everything. So that's why I called it a hype.
To continue on that, I think one of the things we want to answer in this podcast or get a better understanding of is what can we expect of AI for research, and maybe be a bit more specific there. What can we expect from AI for research in the Netherlands? So you're at SURF, Vali, and you have been working on some pretty amazing projects, I think. If you were to pick one of those projects and explain to us what it is and what crucial difference AI made to that project, what project would you pick, or what would that be?
Oh, that's a good one. So I think one of the interesting projects where we applied AI on in SURF, or not one, I will pick some more. So it's they're the medical projects. I would put them in a bunch. So the projects coming from medical science, and they are quite relevant here in the Netherlands. We have some cutting edge university medical centers, and they have some cutting edge equipment and so on. So now we worked with in collaborations with Radboud, UMC, or even the National Cancer Institute in projects for improving diagnosis, for example. So for improving diagnosis in biopsies, in the project we have together with Radboud in digital histopathology, and it's simply gives you the potential to increase the throughput of the pathologist or of the radiologist. So say a pathologist would take 1 hour to classify an image to see if it has tumor cells there. Now the AI could guide him on where to look inside that big picture and pinpoint some potential tumors. And then it will decrease his time to diagnose a patient with cancer or not. It might drop the time to 1 minute instead of needing 1 hour. So I think medical sciences are some form of low-hanging fruit for machine learning at the moment, and the only problem there is with regulations, because machine learning tends to be seen and is partially a black box, so it cannot fully explain its decisions, and this is a problem for medical sciences. But in terms of the quality of the diagnostic, in some fields of medicine, they tend to be superior to even radiologists, trained radiologists or trained pathologists.
I think this was in the news just today that the European Commission was urging to ease the rules for DNA tests regarding COVID-19, etc. Vali, is that something you are involved with as well at the moment, that link that your work has to the COVID-19 situation?
Yeah. So currently, like a couple of months ago, inside my team, we started to develop some potential solutions for diagnosing COVID-19 from imaging data. So we started 2 parallel approaches: one for diagnosing COVID-19 from X-ray images, and the other one from CT scans. We even participated in some competitions with our solutions, so we have pretty decent quality solutions. Though the problem here is that machine learning, in order to really give you the best results, or to give you the best results it can possibly give you, from, of course, given its limitations, is requiring quite significant amount of data, and even more so labeled data, so annotated data. that's how machine learns. You have to tell it what examples are of a positive case and what are the examples of a negative case. So you have to beforehand label that data. And here we encountered the problem of data sharing from medical institutions to computational guys like us. So we hit some walls here, some barriers here of getting actual data from hospitals.
Regarding the regulation, not so much the technical capabilities.
No. It's just regarding the regulation, the privacy of the patients involved, and we just didn't reach these agreements with the hospitals to share data with us. So we just test drove our algorithms on some public data that was very limited. So I think it has potential. There are places in the world where people release larger collections of data, and already some AI systems came to light that showed promise. But here in the Netherlands, we tried quite a lot, but we didn't succeed in really getting a large stream of high quality data.
Is that a difference? The Netherlands compared to other countries in terms of regulation, or Europe versus other countries?
I think it is the second is true. So it is Europe, I think, especially with the new GDPR regulations opposed to other countries, because the data collections we've seen so far come either from Russia or from Brazil or from these kind of places. So not necessarily from Europe. We don't know of any large data collection coming from Europe.
Is data or privacy and access to data the only problem, or is it also a funding, or I don't know?
I think it's also the way that people from hospitals will get credits for handling in this data, because it is quite some effort from their side, and especially in the COVID situation from last couple of months ago, when it was very busy in hospitals, they didn't really have the time to annotate data, and on top of this, say they would do it, then they would need to get appropriate credits for this. And I don't even know if such a credit giving structure is in place currently. So normally the credits are given to the AI researchers, but it's not on their own merit fully.
Vali, you now mentioned a couple of times like labeling the data.
Yeah.
How elaborate is this? How difficult, how much work is involved in doing this?
Yeah, that's a great question. So, and it is really different per application domain, and even inside medical, it's different per application you want to propose. So, if you want to propose an application where you want to do organ segmentation, like in self-driving cars have this pedestrian segmentation and bicycle segmentation, you could have the same in medical images and saying, okay, this is a heart, this is a tumor, and so on. And that is really time consuming, because you have to draw contours to all these small structures sometimes, and it might take in the order of hours to label a scan. And this kind of labeling can only be done by by specialists. So it cannot be like an image of a bicycle and the pedestrian can be labeled by anybody, whereas a tumor cannot be labeled by anybody. So it's very expensive labeling in terms of medical imaging.
I think for the regular pictures, you get the captchas when you go online, just as a regular user, right? You want to go to a website, and then before you can log in, they answer,
exactly.
Or they ask you something. Can you pinpoint what is a traffic light? What is a bicycle, like you say? So,
but they cannot ask what is a lymph node tumor or something. It would be a bit too much, I think.
You really need specialists for this. And if it takes them hours for a single scan, and they are already tremendously busy at the moment.
Yeah, you need to find some incentive somehow to, I don't know, either pay them extra or do something to motivate them to do this. Otherwise, they wouldn't necessarily want to do it just to improve the AIs for nothing somehow.
I think it's kind of interesting, because the specialist, the role of the specialist in the future, especially with the example you give, reviewing medical images for malignancies and whatnot, that can be taken over by AI applications or machine learning applications. Is this something they should be learning? So should the specialists be learning AI, or should we introduce AI into their curriculum and say, this is something you need to be aware of? And 40% or 60% of your time you should be seeing patients, but 40% of your time you need to work on improving AI models so we can become better in the future. How do you see that?
Yeah, I think that's a very interesting point, and I think not necessarily teaching the medical specialists AI, but teaching them how to interact with an AI system more. So not necessarily the techniques that are, because the AI in itself is a pretty complicated science. They don't need to learn a totally different science, but just to interact with AI, because there are some very interesting new ways of for AI to learn. For example, it's called active learning, where you have a human in the loop. That when the AI is not sure, typically, of course, always AI works with probabilities, and if you have to choose between, let's say, tumor, non-tumor, and the AI says 50-50, then you might indicate that it is a case where AI could learn, and then it could put the human in the loop, in this case, the human being the medical specialist. So this kind of interaction with the AI system have to be a bit more, I think, pushed, but again, you have to find a framework for this to happen.
And Vali, how much real world use is there of systems like this? Because you're working on a couple of cases, right? You are driving the research part of this.
Yeah.
Is it already used in practice on a wide scale?
I would say no. There are some examples, but not so to say. Radiologists tend to use AI a lot or something. This is too much to say, but there are cases I can give examples. For example, even here in the Netherlands, there is a project. It's called CAD for TB and CAD for COVID. They come from some commercial company, Tirona and Delftcare. And they are being used in production in countries that do not afford having radiologists, for example. So in Africa or in some other places in the world, they are using these systems in production. Yes. Some other systems were approved by the FDA, also for radiology, by the FDA in the United States. But this is all recent. I don't think it's used at a wide scale in the United States at the moment.
And you mentioned Africa. How do they do this there in terms of getting the data towards the system, and they gather the data in the field and then they upload? Or
yeah, precisely. So they gather the data in the field. They have X-ray machines also there, and then from the X-ray machines they upload the data to some cloud services, I believe, and then the automated systems from Tirana or Delftcare analyze the data and send back the diagnostic.
Wow.
Yeah, because it is really required for countries that do not have a large population of radiologists, but they still have a large population of patients. So that's where the problem lies now.
Yeah. And this is in the medical domain. I know you've been also involved with PlantNet.
Yes.
So that's not on the medical side, but more on the botanical side of things. It's even in the App Store, right? It's a app that is available on Android and iOS, and you've been involved with this.
Yeah. So in that collaboration, PlantNet is a French company, and what they wanted to do was to classify all the plants in the world. So wanted to tackle this problem known as world flora classification. And we helped them quite a bit back then because so all the plants in the world means 300,000 different species of plants, and they had a serious scaling problem back then because you cannot do this on a single computer. So what we did with them, we both extended their algorithm, their neural network, but also parallelized it. So, of course, we come from a national supercomputing center, so that's our bread and butter, to parallelize things to run on multiple machines. So in the end, we ran it on a full supercomputer from France, on a supercomputer scale, basically about 1,300 nodes, similar to the Dutch national supercomputer in scale. And in the end, we managed to train quite an efficient system. It took I think a day. We had full access to the system, to that supercomputer, for a full day. We trained our model in a day, and then it really managed to produce above 40% accuracy for all these 300,000 different plants. So yeah, it was quite a successful example, and then it went into App Store. Yeah, indeed.
That was still only right? I mean,
yeah,
above 40%, you say?
Yeah. But the problem there was. And we're going to a nice point again with data. So the problem there was that 50% of all their plants, so 150,000 plants from their collection, had only a single image to train on. So you wouldn't expect to do well in this situation on 50% of the cases. So you can say as the upper limit of classification would be 50%, and we got 40.
So one picture is like a picture taken from one plant.
Yeah.
And that's okay.
That's it. That's what your model should learn from, and it's really difficult.
What would be an optimum amount of pictures, number of pictures?
I think at least 10, 20 would be a minimum.
Yeah. For each species.
For each species, or in general for each classification target that you want to classify. Not only for plants in general, even if you want to do face recognition. I mean, it's unlikely you're going to do it from a single face.
So there's a lot of, I think, very interesting stuff going on. A lot of interesting applications and developments in this field. Is there something you encountered recently, Vali, which surprised you? An AI application which really surprised you, and this can be surprised in a good way, but also in a bad way. And if it is, what was it?
Yeah, I think we worked. Again, I'm going into medical. Probably I have some passion for this. So we are having a very nice collaboration with the Dutch Cancer Institute, where we want to generate fake CT scans. So like you see a lot of images around and applications on the App Store that you can generate a fake face, and then people are all using it to generate all sorts of deep fakes and and stuff like that. So what we did with NKI, we wanted to take one step further and try to generate images in 3 dimensions. So a computer tomography scan, basically. That has a lot of computational drawbacks, because simply being in 3D, you have a lot of more computation, and a lot more complicated model is needed to make sense of all that high dimensional data. The whole idea there is to create fake patients, fake internals of patients, and to see if those fake patients have really value, in the sense, can we solve the problem of data sharing by sharing fake patients instead of sharing real patient data? That was the question we wanted to answer, and it was a bit crazy at the beginning. We thought it's really unlikely we're gonna come up to anything like that, but we are getting closer. So we have shown this kind of 3D CT scans to radiologists. They can spot it is fake, but it's not like for our naked eye we cannot spot it is fake. So we are close. We are getting closer. So this is one of the surprising things, I would say. I wouldn't necessarily expect that.
Wow, yeah, that's amazing, Vali. We talked about in this podcast series about the website "This Person Does Not Exist," where a face is generated and that looks remarkably like a real face, right? It's hard to distinguish. Is what you guys are generating on that same level in terms of detail? It's not a face; it's the inside of a person.
Yeah, I would say say yes, or maybe let's say almost, because also for the deep fakes, there are some special features that you can look at to see if a face is fake or not. For example, the ears of persons. They're even called, so these models that generate data are called, the class of models is generative models, but this specific type is generative adversarial networks, or GANs, and the ears are even called GAN ears. So if you look online, GAN ears, you're gonna see that they create artifacts in the ears.
Are they like pointy ears, like hobbits, or how?
Yeah, sometimes the ears, or they are not symmetrical. You can even see in the GAN eyes, some eye can be of a color and some eye of a different color. So if you look at this kind of details, you might be able to spot them better. Same did for our CTs. So we generated chest CTs. And one of the clear features that was wrong was, for example, that our ribs were not always continuous. So you would see some very, very tiny jagging factor there in the ribs, and that, for example, a trained doctor would immediately see that. So it's still work in progress, but I think it's really surprising that it generated so well that it could, for example, generate the heart at the right place. It could generate some important parts at the right places.
And this would circumvent the whole regulation, because that person does not exist, right? That patient does not exist. Yeah. It would really help to speed up the training efforts and the development of the systems.
Yeah, because then you would need only, you could even deploy this algorithm into the hospital itself, and then the algorithm will generate as much data as you want, following that hospital's distribution, because this is also an important thing. We were discussing before about the COVID data. Now, if the US share COVID data or if China shares COVID data, the population is not the same. So they have a totally different distribution across the globe. So it might have some small differences when applied to population from the Netherlands, for example, the COVID. So that's why you would need some global collection of data in order to tackle global healthcare problems. And this would serve this point, because this research that we are doing would serve this point, because every hospital would be able to run this algorithm, generate data following its own distribution, and then share in some sort of global repository, global data repository for a given affliction, for example, for pulmonary cancer or whatever. And then you would see how pulmonary cancer looks in all parts of the world.
So I think there are two interesting angles to what you're describing now, Vali, because on the one hand, there is the data collection part, where you need to collect data across all the regions of the world to have a good mix of different people living across the globe.
Yeah.
So that is something you need to do. And you also touch upon something interesting, like running it locally. I'm from the cloud domain,
Yeah.
and I'm always thinking, whoa, you need something that's so powerful, you cannot run this on premise, but would that work? Could you actually run the AI system or algorithm locally in the hospital?
Yeah, that's a good question. You would need some hefty computer infrastructure to run this. So some hospitals have it, especially the UMCs. But I mentioned the local training just to avoid the data sharing again from the real data that would be used to generate fake data in the end. But if you would be able, let's say you as a hospital would be able to use some cloud provider, that would be much, much better. So if you would be able to, in a safe way, secure way, push your data to the cloud provider, train this system there on your real data, and then take the data out from the cloud provider, then the algorithm to run it and generate new data can be run on a laptop. So, but the problem is training the algorithm on your real data. That takes a long time, and you need strong computing system to do.
From my understanding, there are two parts. You first get a large bucket of data.
Yeah.
Then you train an algorithm, and once the algorithm is trained, you have the algorithm, and you can use that algorithm on your own computer to classify.
Or to generate, in this case, or to generate new data. Yeah, you can do it on your laptop or yeah.
And do you think it's realistic that in some scenario we all share data globally in some big cloud repository where we can run our algorithms and have a super data set for training? Is that something
that would be the
can achieve?
Yeah, that would be the holy grail, but I think we are hitting issues with this. So if we would be able to push data, let's say from hospitals into some global collection, the real data, then we wouldn't need the system we are developing. We just try to alleviate this problem because we see that there is a lot of resistance to this, to push data, medical data inside the global repository. But that would be, so the whole idea is to have indeed some mix of data, as Andres was saying, some mix of patients from around the world in a shared collection. That would be the aim. And now to achieve this, you can either use the real data, but that seems unlikely from policy perspective, or to use generated data.
Yeah. So the deep fakes, I think that's fascinating that
Yeah.
you create a deep fake from a CT images. Is that as good as the real thing? So if we would generate those and we would put them in a shared repository somewhere globally, then we have a big deep fake repository we can use to train models. Would that be useful? Is that something we can be doing or
Yes.
thinking about? Or?
Yeah, that would be the goal. At the moment, they did it for natural images. So the people that made the deep fakes, they made deep fakes of everything, so also of cats and dogs and everything. And they tried to, instead of training systems, AI systems on this big data set called ImageNet. ImageNet, by the way, is the data set that started this AI revolution like 7-8 years ago. And instead of training their new models on ImageNet, they train models on a recreated ImageNet. So something like we want to do with the cities for medical field, but they did it for natural images. And the images are useful. They are not at the same usefulness level as the real data. So let's say a system would get 80% accuracy when trained on ImageNet and would maybe get 75 when trained on this kind of data. So it's less informative, but it's still very informative. It's not like you cannot make any sense out of it. No, it's really good. And we need to find ways to train better generative models. I think we should be able to close the gap.
Is there also a gap between the research community and commercial providers, the big tech companies, in approaching this or working with this?
I think the research community has a problem compared to the big cloud service providers, for example, with regards to resources. So these AI models tend to require a lot of computing resources when you want to achieve a state-of-the-art AI system. So you can also use your laptop to develop an AI model, but then if Google uses a full data center, you pretty much cannot match that. And there are issues. So I talked with several researchers, particularly in the natural language processing field, where these big cloud giants are proposing extremely large models for language translation or for language generation or for any task related to this. And in order to reach those very high performance, high accuracy systems, they train on billions of data points. And they need really big supercomputers, something that the Dutch researchers can only ask us for. But we cannot compete in terms of resources with Google.
With the supercomputer we have in the Netherlands.
Yes. Yeah. So a lot of people are using the supercomputer, the Cartesia supercomputer and the LISA compute cluster here in the Netherlands to develop language models, for example. But of course, we cannot match what Google has. And they are using, Google uses internally their resources to develop new algorithms, of course. So the researchers from academia, it will be more and more difficult to compete with the researchers from the commercial institutions.
Yep, because then you have kind of two different teams of researchers. You have the researchers working in the research community, and you have researchers working for the commercial companies. Do you have a view on the amount of AI specialists, the number of specialists that would be working in Google in the AI ML domain? Would that be thousands of people?
Yeah. It would be thousands. Yeah. So it's still, I mean, of course, all the universities combined will have a much greater pool of human resources to work on these AI systems. But where Google tends, and not only Google now, but all the other like Amazon tend to win, is having extremely large compute infrastructure.
And how is this for China?
Yeah, for China there is things are similar. You also have Alibaba there, and Alibaba has again huge compute infrastructures and huge AI teams, and they work on similar subjects as Amazon, for example, being recommender systems or language translation tools or things like that. You also have a separate, let's say, focus for these industrial companies. So whereas you would see in research that we try to, for example, work with medical imaging or work with even more exotic, for example, trying to replace some chemical processes with AI processes or some astrophysical processes with AI processes or estimate them with AI processes. You don't really see that in the big commercial companies. They are more oriented towards their products in the end, and they don't have astrophysics or
different goals that they work towards.
Yeah.
But you collaborate with some commercial companies in your work?
Yeah, we collaborate with Intel. We have a long-standing collaboration with Intel. Actually, this motivated us to increase the AI work we are doing here in SURF. So we started in 2017 with them, and as part of our collaboration with Intel, we worked with other providers. For example, with Amazon, we have some common research together with Amazon. We have common research together with CERN and other parties. But Intel is a bit different because it's not necessarily a cloud service provider. It's like the CPU provider for the cloud service providers. And they also provide CPUs to, for example, CERN. So they are also interested in the physics. Since they provide CPUs to CERN, they are interested in training AI systems that understand physics. Yeah.
Speaking about CPUs, I always read about that you need GPUs to do the real AI research?
Yeah, that's not always the case. It's also some marketing battle between NVIDIA and Intel. And at the beginning, you were like 5-6 years ago, indeed GPUs were much better, but that mostly came from the software support that they were having. So there were a lot of investments in software optimizations for GPUs for machine learning, and Intel was a bit left behind, so it needed to recover this slack. In the end, it did. So we even have a publication where we compare CPU-based training with GPU-based training, and we just see that the difference in training times comes just from the difference from the peak performance of the CPU versus the GPU, and that's like a factor of 2 normally, or 3. It's not like a factor of 100, as NVIDIA likes to say. Yeah, and you have a big advantage in terms of CPU-based training, and we want together with Intel to exploit this advantage. Is the memory that you have in a CPU node compared to the one you have on a GPU card, and this tends to be an order of magnitude higher or even more. It's advantageous for the CPU, of course. So you can have hundreds of gigabytes of RAM, whereas in a GPU you can have 32 gigabytes of RAM. And this really limits the size of the models, and in the end the accuracy your model can achieve. So we can maybe train a bit slower than on GPUs, but we can train much better models than a GPU can.
Vali, also looking at the time, maybe one last question. You mentioned we need an AI framework. And from what I hear, the framework needs to have data, infrastructure, compute, but also a collaborative framework. So if you would describe that framework, maybe I'm missing something, but describe that framework, and also what would be the most important thing to focus on in that framework that's not yet in place?
Yeah, so I think the framework would indeed be composed of. So the whole idea is to work on some real-world problems or very relevant questions for the society. So the ones that tend to pose these questions or requirements are the domain scientists. So on the first hand, you have the domain scientists that have a problem. They can formulate a problem, but they don't necessarily know how to tackle it with these data science techniques. These domain scientists also tend to have a lot of data, domain-specific data. They generate that data as part of their processes. And then they would, to continue the framework, or the framework would start from the domain scientists. Then we need to find a way to incentivize the domain scientists to annotate that data that is from their field, because normally they wouldn't annotate it in a way that would be useful for machine learning.
And annotate is put a label on the data that we know, or that the computer knows what it is.
Exactly. Because all these machine learning approaches are supervised machine learning, so you need to know the ground truth in order to train them. So then they will need to have to put this label on the data, and then they will need to meet. Also, the labeling procedure needs to be discussed with the persons from the machine learning AI communities, because they are the experts in data science. So they should together find the best way to label the data. And this process is sometimes ignored, but it is very, very important and time-consuming. It's probably the most time-consuming. Everybody looks at AI training. It takes 10 days to train a model. Yeah, but it takes 1 year to label the data beforehand. So first of all, this has to be done. And then the AI persons would need to have access to large-scale compute infrastructures, and would need to have to get help from the persons that are managing that compute infrastructure. So it's like a 3-way construction from domain scientists, AI scientists, and AI, let's say, engineers, or HPC engineers. That's what I mean. And this 3-way combination can lead the field, I think, further.
Sounds like you need an organization that has a motto: driving innovation together.
Yeah, I think that should be it. Yeah.
Surf.
Yeah, I think since we are we have this role of matchmaking here in the Netherlands, I think we are in a unique position to drive this further, to be honest.
Vali, how is your team involved in this website, white paper, consultancy? How do you make you and your team available to the research community?
So we participate in hackathons, for example, and we make our efforts available to, for example, research groups here in the Netherlands. We had, and those hackathons can range from a week. We had a 1 week hackathon, for example, in January, together with the eScience Center, where we have held various groups. We also, for example, we wrote the best practice guide of Praise with respect to deep learning. It is on the Praise website. We are giving a lot of trainings where we want to help our users get up to speed with machine learning.
I saw a great white paper from machine learning.
That is so we had a very nice activity last year called Deep Learning Enhanced HPC, where we tried to replace or displace parts of scientific codes with machine learning processes. And we got 4 groups on board, and they were pretty successful. We are going to organize also a webinar about this, I think, at the end in September.
Okay.
And but yes, we have released a white paper explaining all approaches we, together with the scientific groups, took to basically advance the state of the art of their applications.
Right.
And that's what we tried in that project. What I think it links very well to what you were asking about this framework. I think that's where we tried to explore this kind of frameworks, where we work together with the domain scientists.
And why is it called deep learning, Vali?
It is called the deep learning because most approaches that we used were from the deep learning, let's say, subfield of machine learning. So deep learning means that you would have a neural network that is very deep, that would have more than, normally a neural network would have like an input layer, an output layer, and a layer in between. If you have more than one layer in between, we call it deep learning.
You mentioned earlier that Google had billions of layers. Is that related to this deep learning, or are these other data points or layers? How?
No, so the billion of data points I was mentioning earlier refers to the data. So the layers are part of the model.
So there's a difference between the number of entries you have in the data you have collected, and then the model you use to process that data.
Yeah, exactly. So having more and more data, more and more of these data points that, for example, Google, Facebook, of course, is they have a lot of web services. They can gather a lot of this data. So there are billions of data points. But then you could have a small or a medium or a very large model that would analyze this data. And the best of both worlds, of course, is to have billions of data points and the model with billions of parameters. But in order to train that beast, you would probably need the computing power that Google has.
But the bottom line is, I think we can't do it alone. We need to see collaborations as much as possible and work on a framework.
Yeah, but I still think we didn't exhaust all our computational resources. So I still think we should, the first step would be to strengthen collaboration between domain scientists and our group, the HPML group. That our group would hold our group would be in the place of the other 2 groups I've mentioned before, the AI guys and the HPC guys. We try to bridge this gap. So if we would connect our group more and more with the domain scientists, it would already be a step further than it is today. And then we will see, if we exhaust the compute resources of the Netherlands, then would be a next step to go for Google. That's how I would see it.
Great. Vali, thank you very much for this interview.
Thank you.
That was really good.
Thanks.
Dit was het interview met onze deep learning collega Valeriu Codreanu. Inmiddels is Duuk weer terug van vakantie en heeft de eerste versie van de podcast kunnen luisteren. Duuk, heb jij vond je ervan?
Ja, leuk. Ja, jammer om niet bij geweest te kunnen zijn, maar heel leuk om te horen waar Vali allemaal mee bezig is. Blijft me toch elke keer weer verbazen hoe breed zijn team bezig is met machine learning inzetten. Ja, heel leuk.
Ja, mooi. Ja, mijn persoonlijke favoriet is nog steeds dat verhaal dat hij, wat hij vertelde van dat hij eigenlijk deepfakes maakt op basis van CT-beelden en zo eigenlijk een oplossing heeft voor het delen van hele private sensitive data. Zeg maar zo'n beetje zo'n controversiële techniek dat hij die inzet om goede dingen te doen. Dus ik vind
This patient does not exist. Ik had het ook opgeschreven. Heerlijk.
Nee, ik kan daar...
Ja, en wat ik wel cool vond daaraan is dat hij heeft het op een gegeven moment over zo'n deepfake repository, waar je dan die medische data images eventueel in zou kunnen verzamelen. En dat dus ook echt kan. Het idee snap ik dat heel interessant en goed is. Maar dat ze dat dus met andere natural images op basis van ImageNet al getest hebben. En het best wel goed lijkt te werken. Klinkt al als iets super veelbelovends voor de medische sector. Waar toch wel altijd een uitdaging is met hoe je veilig en verantwoord je data deelt. Op een manier die wel onderzoek over de hele globe mogelijk maakt. Want we weten gewoon dat medisch mensen verschillen per gebied. Dus super, super interessante uitdaging.
Ja, en het geeft ook mooi... Kijk, het is ook een beetje altijd de vraag van wat doe je... Want aan de ene kant is privacy en datadelen natuurlijk een heel groot ding en heel belangrijk. En gelukkig hebben we goede wetten die daarop letten. Maar aan de andere kant zie je wel ook onderzoek doen, want je gaat mensen ook verder helpen met je onderzoek. Dus het is altijd een beetje hoe zeg je dat? Een evenwicht wat je moet bewaren, maar je moet er natuurlijk wel vooruit. Dus ik vond het wel mooi om dat te horen, hoe dat allemaal
zeker die medische sector is super uitdagend ook. Ik denk dat daar ook, het onderzoek, hoe relevant wil je het hebben op dit moment in de huidige wereld waarin we leven? Volgens mij eindigt Valeriu ook ergens nog met oproep om te blijven samenwerken. En ook te kijken van, hoe kunnen we nou als Nederlands onderzoeksveld zorgen dat we onze eigen resources ten volle benutten.
Ja.
Volgens mij is zijn team zeker onderdeel van een van die resources die veel mooi werk verzet.
Ja,
heel cool.
Zeker. We hadden ook nog even die whitepaper aangehaald in de podcast. We zullen ook de link naar die whitepaper in de beschrijving van de podcast zetten, zodat mensen daarop kunnen klikken als ze meer willen weten wat er allemaal gebeurt binnen Valeriu's team.
Ja, precies. En ik denk als je er als onderzoeker echt mee aan de slag wilt, dan zijn ze vast ontzettend bereid om je te woord te staan. Wat zoals in het hele verhaal naar voren komt, super interessant. Plantnet. Ik gebruik het zelf thuis om mijn plantjes te begrijpen. En ook al die medische onderzoeksprojecten, super interessant.
Yep.
Wat misschien nog wel leuk is, we kregen van de vorige podcast eigenlijk een soort van kijkersvraag of luisteraarsvraag terug. Van onze collega Iris. En die vroeg zich af, in mijn woorden geformuleerd, als we onderzoek doen met artificial intelligence en machine learning, wat dat eigenlijk betekent voor de wetenschappelijke manier van werken en dan specifiek de reproduceerbaarheid van onderzoek. Nou heb ik daar zelf niet zo'n antwoord op, ik ben namelijk geen onderzoeker. Maar Thomas, ik weet niet, heb jij daar een beetje zicht op?
Ja. Nou, ik was onderzoeker in mijn vorige leven, moet ik zeggen. Dus, maar hoe dat... ik weet dat reproduceerbaarheid is altijd een ding. Ik weet niet precies de getallen, maar ik weet ook dat veel onderzoek niet reproduceerbaar is. Dus, en dat is zeker een issue. Ik vind het een goede vraag. Ik durf eigenlijk niks over te zeggen wat betreft machine learning. Ik denk wel dat het een onderwerp is waar we misschien waar we naar moeten gaan kijken of we daar meer te weten van kunnen komen. Want het is natuurlijk ook de transparantie van AI is denk ik een vraag. Maar ook van als je AI hebt en je past het ergens op toe, kan je dat dan ook vaker gebruiken. En ik denk het, even op basis van mijn eigen ervaring, ik denk het niet. Want het hangt ook inderdaad af van wie of hoe je data eruit ziet en wat je allemaal in je data, hoe goed je dataset, of nou goed is niet het goede woord, maar de dimensies van je dataset, om het zo te zeggen, daar kan je een bepaalde vraag mee beantwoorden, maar dat kan je waarschijnlijk niet op een andere dataset, want dat hangt van je dataset af. Ja, het wordt een beetje technisch, maar ik denk, ik laat hem even parkeren voor nu en dan, ik denk dat het een goede vraag is om te kijken, transparantie van AI en wat er allemaal bij komt kijken. Dus ik hoop dat er mensen misschien luisteren en zeggen, hey, dat is mijn ding. Als dat het geval is, stuur even een berichtje.
Het verwijst in ieder geval, denk ik, naar de noodzaak om te zorgen dat we onze datahuishouding op orde hebben en ja, mogelijk ook die algoritmes zoveel mogelijk met elkaar kunnen delen in het onderzoeksveld, denk ik dan toch?
Ja, kijk, als je met AI, als je volgens mij, of even terugvallen op wat ik vroeger deed, als je een correlatie hebt, dat is gewoon een associatie tussen twee dingen die met elkaar samen kunnen hangen. Dat wil nog niet zeggen dat dat in een andere populatie ook zo is. Dus als je ergens een correlatie vindt tussen twee dingen, dan wat je zou doen, dan kijk je in verschillende populaties. En als je dat verschillende keren kan aantonen, dan zeg je van nou, deze correlatie is waarschijnlijk zo. En we zien hier een associatie tussen deze dingen. En we kunnen redelijk zeker zeggen dat die er is. Maar hoe dat met AI werkt, dat vind ik wel een hele goeie. Dus, of wat we daar tegen gaan komen, ik denk dat we daar gewoon naar op zoek moeten gaan.
Ja, super interessant. Wat je al zei, Thomas, inderdaad. Als iemand anders hier ideeën over heeft. Wij weten het ook nog allemaal niet zo goed. Of andere vragen die je na de podcast hebt, stuur ze vooral even op naar ons. Dat kan het makkelijkste via e-mail naar ai-info@surf.nl. Dan krijg je ons gewoon direct te pakken.
Nou, volgens mij was dat hem. Of zijn we nog dingen vergeten?
Ik denk dat hem was. Dus we moeten hem nog even eindigen met een coole slagzin.
Oké, nou, zal ik de slagzin
Zeg nog even een slagzin, Thomas.
Ja, nou, echt, super leuk dat jullie allemaal geluisterd hebben. Goed dat jullie geluisterd hebben. Ik hoop dat jullie er iets aan hadden. Blijf vooral luisteren, want we gaan heel veel interessante mensen spreken als onderdeel van deze podcast. Dus blijf vooral checken welke nieuwe podcasts we hebben. En dank jullie wel voor het luisteren.
Yes, tot de volgende aflevering.
Ja,
ja precies.
Tot de volgende aflevering.